have a data transfer between two nodes, that is between two stations only, sending the frame and getting the acknowledgement there. As a first approach, and we have discussed the stop and wait protocols and the sliding in the protocol for the successful and reliable transmission of each and every frame there. And it is one type of scenario, that is a networking environment. And another type of the scenario is we are having a single source station is there, and number of receivers, that is it is one terminal and it is another terminal and it is another terminal. So for in this type of networking, that is it's some sort of a broadcasting network. Okay, it is come under a switched communication network category, and it is come under a broadcasting. That is, this particular source station is going to be sending an information to this particular number of terminal devices. And moreover, these terminals are also going to be sending information to this particular source station. But here, for the information transfer of in this particular networking, what we are going to do is we are going to use one media that is called as a medium access control or a media access control. It is going to be responsible for the transfer of the data from multiple terminals towards the source and the source to the multiple number of terminals there. Okay. So, and what is the purpose of this particular MAC is the responsibility of this particular MAC is while sending the data from this station to the number of terminals which are connected over in this networking environment, it has to select what is the specific desired destination device, that is where it has to transfer the data. And after selecting the specified destination, how the information is going to be transferred reliably from this particular source station to the a number of terminals. But already we are started the discussion of this MAC. That is, suppose where in the sense it is going to be selected based on the centralized networking and distributed networking. Okay, okay. Just I will open the previous class. That is the previous class we discussed that. In this particular scenario, this particular MAC is going to be responsible. So, in the MAC, what the MAC is going to do is what is the specified or the desired destination device and how the data is going to be transferred over there. And that too depending upon the centralized networking and distributed networking. Okay, now we completed this particular desired destination selection. Okay, next one is how the data is going to be transferred for those number of terminals. So how data transfer is going to be taken by this medium access control is in two ways. The data is going to be taken out to all the terminals. One is synchronous, and second one is the in a synchronous manner. This mark synchronous in the sense all the terminals are going to be taken the traffic with the same capacity. Means that suppose if the terminal is going to be transferring one amount of data 1 KB, the remaining terminals are also going to be taken that only that particular data. Why? Because this MAC is going to be uses the synchronous data transfer. Means that from all the terminals only the same amount of traffic is going to be allowed to the source station, and from the source station the same amount of traffic is also going to be possible. That means it's not depending upon the capacity of the terminal. But in asynchronous, what we are going to do is because depending upon the capacity of each and every terminal and depending upon the priority of the device, it may give a small information or it may give less information or it may give the more information. So synchronous in the sense the same traffic rate is going to be maintained for all the for all the terminals, what for all the receiver stations. But in asynchronous mode, we are not having a fixed capacity of each and every terminals. That means depending upon the capacity of each and every terminal, the information is going to be selected and it will be transferred through this particular MAC control. Like that, this particular MAC is going to be follow either synchronous mechanism or asynchronous mechanism. Why? Because we don't know that the information is going to be existed for all the terminals is common or different. Okay, if you see here, simple example, what we discussed in the previous class, that is in an organization, if this particular chairman is going to giving the information to these particular categories, deans, HODs, and the students. So the information given to the students may be small, and the information given to the deans may be more, and it may be somewhat higher when compared with your dean and the students. Like that, the information which is given from the central node, from the source station, with information given to all these terminals may varies depending upon the position of these particular terminals, depending upon the capacity of these particular terminals. So, but in the synchronous mode, all the terminals which are connected through that particular MAC, whatever the media in between the source and the receive terminals we are having, the MAC is going to allow only a common data transfer with the same capacity. Okay, the same amount of information may be transferred in the synchronous mode. But in asynchronous mode, depending upon the capacity of the terminals, the information transfer is going to be takes place. That is about synchronous and asynchronous. Okay, now we have seen that the main function of this particular MAC. Okay, but here, in order to implement this, how an information is going to be transferred with the same traffic or the different traffic, or how we are going to select a particular device, and from that particular device, how a frame is going to be transferred from this particular terminal devices to the source station. So again, in this particular MAC, we are going to use some algorithms or the protocols or the techniques we are going to use in order to implement this particular MAC control unit. That is for the implementation of these particular questions, that is where and how we are going to implement this particular MAC control unit is going to be implemented with the help of different techniques or the different algorithms. Okay, and again, we are having the different approaches there. Different MAC techniques are there, which are categorized based on different factors. Yes, one is the random access. So the random access in the sense when a number of terminals are going to be connected to the source station, any one of the terminal may take the chance to send the frame to this particular source station, and that too in the random access. While sending any frame by any one of the terminal, it may collide with the frame of the another terminal device also. Why? Because randomly all the terminals are going to be in action. So we are not going to stop the frame transmission of each and every terminal device there. That is about random access. Again, for the implementation of this, we are having the different protocols. We will see one by one, sequentially. We will discuss each and every one. And second approach is based on the round robin. So all the terminals are going to be selected based on the round robin terminology. That is, one by one is going to be selected. Like that, we are going to transfer the frame in order to eliminate the collision, or in order to eliminate the overlapping of the frames from the different terminal devices. And next one is the reservation. That is like your first come first out. So all the terminal devices which are going to be communicating with one central node, those are going to be selected one by one based on the preference and the priority. That is nothing but the reservation. And third one is the channelization. That is availability of the medium access control, whether it is an ideal or the busy. Based on that, the terminals are going to be communicating with your source devices. Okay, now we will go for this particular random access, how the number of terminals are going to be transferred the data. And before that, we have to know some of the important goals of this particular MAC. Why? Because this MAC is going to be responsible for everything. That means these terminals are going to be sending the frames with the help of any one of these protocols from this particular terminal to this particular source station, or the source station may transmit any data to this particular terminals also. And each and every one, they are sending the frame, and at the same time they are going to receive the acknowledgement also. That is, we are going to implementing the full duplex terminology here in between the source and the receiver stations. So for that purpose, the MAC has to maintain something in order to, for the purpose of reliable transmission in between the source and the receiver stations. That is, mm, it is going to be performing, the MAC has to check that the fairness of the data transfer. So the fairness in the sense, whether each and every data transferring from all the peripheral devices is going to be accessing or is going to be taken out by this particular MAC unit at the same time, or they are transferring without any delay or not. So it is going to be check the fairness of the data, whether they are transferring at the same rate, at the same time, are they allowing without any delay or not. Like that, it is going to be checked. Along with that, that means not only it is taking the frames, at the same time, this Mac is going to perform in some functionalities. It is going to be checking the characteristics of the information, whether the information is going to be transferring reliably, securely, and safely. So to perform that, it is going to be taking the actions, that is checking the fairness. At the same time, it is also going to be taking the collection of the receipts also. So what is meant by receipt is, suppose if any frame is going to be sent from this particular terminal, again the Mac has the responsibility to give some receipt. Means it has to give some acknowledgement toward this particular terminal device. Some information is taken from this and it is going to be shared to this particular desired destination, either to the terminals or to the source station. And at the same time, recovery is also going to be taken by this particular Mac. Recovery in the sense, if any one of the frame is lost or damaged, as we discussed in the earlier classes, this Mac is also responsible for the recover of that particular lost or the damaged frames from any one of the terminal devices. And along with that, some functionalities are there: reconfigurability, compatibility, reliability, like that. Okay, reconfigurability in the sense, suppose in your distributed system, in the distributed, how we are going to transfer the information is from one main node to the sub node and sub node to the another node. Like that, we are transferring information. Suppose in between the main and final terminal, in between that, if any device is failed, then again it is going to be taking another device there. That is nothing but the networking environment is going to be reconfigured there. Okay, we'll go for simple example here. Suppose if any information is going to be accessed from the director or the chairman to the students, and if it is going to be using the distributive mechanism through deans or the two HODs, suppose if through HODs it is performing the networking environment, and if it is fails, this particular system is failed through HODs, then again the networking environment is going to be reformed, that is reconfigured like that. That is, it is going to be selecting another source in order to transfer the information towards this. That means while sending the information from one source to the one terminal through any other terminal devices, the reconfigurability may be made. That is depending upon the type of networking environment. So that is nothing but the reconfigurability. So this Mac is also going to be checked that. So if any one of the terminal is failed, so it is going to be taking the help of another terminal device to transfer the data, to take over that particular data transfer for the reliable and the secure transmission. Okay, next, compatibility in the sense, all the terminal devices, when you are connecting a number of terminal devices to this one, all these particular terminal devices should provide the data only in the same format. That means the framing should be common for all these particular terminal devices. Suppose if it is using one type of frame and it is using another different type of frame and another different type of frame, we can't provide the compactness between all these terminals. If they are compatible, then we can take the another terminal device to take the help for another terminal device. And if they are different, no need to take the help, no need to take the help of the another terminal device. That means they are going to be incompatible. Like that, the Mac is going to be provided. Okay, these are the some of the responsibilities taken by this particular Mac control protocol. Okay, now we will see that how each and every frame will be transferred to this particular source station without any damage or the losing of the frames, as we discussed in the frame control and error control. Okay, in the first we will go for random access techniques, in which how the data transfer is going to be taken place. Okay, these particular random access techniques are called as Aloha protocols. These are called as Aloha protocols. Okay, from where this particular Aloha name is arised is, mm, according to the basic history regarding this particular protocol introduction, we have one special university, and the university name is the Hawaii. Okay, listen carefully. It's very interesting. Yes, are you following? Just respond anyone.
Yes, sir.
Okay, okay. See, the speciality of this particular Hawaii University is this particular Hawaii University is located on the islands. On the islands. This Hawaii University is located at the nearby the islands. So to communicate any data in this particular university, and as it is implemented in the location of islands, this Hawaii University is take the chance to build a centralized networking environment. Okay, it builds a centralized networking environment means that it is maintaining one central node, and it is maintaining different number of terminals. Let us say that it's a terminal 1, and let us say that terminal 2, and let us say that terminal n, and all these terminals are related to each and every island. So one terminal is regarding one island, and another terminal is related to another island there. So in this particular organization, or in this particular corporation, for the purpose of information transfer, this particular central node which is maintaining this is going to be communicating all the terminals which are available in this particular islands. So if this particular central node wants to send some information to any one of the terminal, it is going to be transfer the information. At the same time, these terminals are also going to be communicating with this particular central node. See, what is meant by centralized networking environment? Okay, here, whatever the basic structure of the centralized networking environment, we consider that the broadcasting network. One source station is going to be sending the information to the number of terminals. At the same time, number of terminals are also going to receiving the information to the source station. So now, whatever the structure they implemented, it is also like that. It is maintaining one source station, one central node, and it is having the number of terminals there related to each and every terminal. So the name of that other is Ambro. The other name is Abramson. Was created this, that is a centralized node or a central node is created like source station, and number of terminals are created related to each and every island. So the information transfer in that particular organization is communicated among only these three computer networking environment. Okay, all these are the computers which is where some computers are maintained as centralized node, and some computers are maintained as a terminals related to each and every island. So here, whatever the broadcast networking we are studying, it is same as this, isn't it or not? So like this, how they are communicating is with the help of this particular Aloha protocol. That means the first introduced protocol for the random access or for the information transfer in your centralized networking is implemented there. So where it is implemented is in the Hawaii University it is implemented, and the name that is as it is developed in the islands area, and it is developed by the Amramson. The name given by this particular other name and the position of the islands and the university name Hawaii, that is going to be called as the Aloha Protocol. So what is the basic terminology in Aloha Protocol is, see, when any one of the terminal is sending the information to this particular centralized node, suppose let us say that if these particular terminals are going to be performing the data transfer at one frequency, let us say that f1, f2, f3, and so on. Okay, and if this central node is going to be transferring at some other frequency, that is, let us say that if all these terminals are going to be taking the data at the same frequency, and if this particular central node is going to be performing the data transfer at another frequency, let us say that f2, so this central node is going to be broadcasting this central node is going to be broadcasting the information towards all the islands or all the terminals, and at the same time these terminals are also going to be sending the information to this particular central node also. So this particular frequency is nothing but it's a broadcast frequency, and this particular f1 is nothing but it's a random access. Why? Because all the times this particular central node no need to maintain the information, no need to collect the information from all these terminals. Okay, and this central node is going to be sending the information towards all these particular terminals. Okay, here in the Aloha protocol, on what basis all these terminals are going to be communicated with this central node is, okay, let us see the basic principle. How each and every terminal is sending the information to the central is, suppose if you are taken that if terminal 1 is sending one frame, if terminal 1 is sending one frame, and let's take that the amount of the time taken by this frame to for the purpose of transmission is tf, and another terminal is also going to be sending another data. But when this particular terminal is sending another frame towards this particular source, at what time it is going to be started is at whatever the time it can it is wish to transmit, at that time this particular terminal may start its transmission. Why? Because it's a random access, so no need to provide a particular procedure, so any terminal can transmit at any time. That's why this type of protocol, Aloha protocol, can be treated as free for all, so no restriction for any terminal device. All the terminal devices may send at any time. So suppose if terminal 1 is sending one frame TF, and another terminal is also going to be sending another frame, and suppose if the time taken by that terminal is TF. So what happens is during the time of transmission of terminal 1 frame, the terminal 2 frame is also going to be in transmission, means that there is the collision in between the frames of the terminal 1 and terminal 2 devices. ఇప్పుడు ఈ రెండు టెర్మినల్ డివైసెస్ ఫ్రేమ్స్ ట్రాన్స్మిట్ చేస్తున్నాయంటే ఒక టైంలోనే ఏదో ఒక టైంలో అలాట్ చేయబడ్డాయి అంటే ఏమవుతుంది, ద సమ్ అమౌంట్ ఆఫ్ ఫ్రేమ్ ఆఫ్ ద టెర్మినల్ 1 ఈస్ గోయింగ్ టు బి ఇన్ కొలిజన్ విత్ another frame of the another terminal device, and some other terminal may also start its frame transmission in at some time interval. Suppose if it is started at t naught, and if the t1 is going to be started at another terminal, let us say that it is a terminal 3 and it is a terminal 2. So terminal 3 is going to be started at t1 and terminal 2 is going to be started at t2. So what happens with this? All these three frames are going to be in collision. So no frame is going to be transmitted successfully. Why? Because T2 frame is also collision with this, and T3 is also collision with this, and T1 is also in collision with this. So no frame is going to be successfully transmitted there. But how these particular frames of these particular number of stations are going to be transmitted to the central node is, okay, there it is implemented, but now we are going to use in a centralized networking environment. Okay, what is the concept we are studying? That is MAC unit. So what this particular MAC unit is, how these particular terminals are going to be sending the data successfully is with the help of this Aloha protocol. So what the Aloha protocol is implemented in order to eliminate the collision of all these particular frames is, see, if this particular frame first frame is taking the time of TF, so the next frame is also in collision with this, and that means this much amount of time is going to be in collision with the frame of second terminal device, and this much amount of time is going to be in collision with another frame which is sent from the terminal 3 device. So only this part of the frame is going to be sent over securely, and remaining part of the information is corrupted, or it is going to be in collision with the remaining frames. So for the successful transmission of each and every frame, what it has to do is, what is the even though the collision is going to be taking place, what is the total amount of time each and every frame is taking? Now we will calculate that. See, suppose already we defined that TF is the time taken by the frame to transmit. ఇప్పుడు ఈ TF కాకుండా ఈ టీఎఫ్ పీరియడ్లో ఎన్ని నెంబర్ ఆఫ్ ఫ్రేమ్స్ ట్రాన్స్మిట్ అయినప్పటికీ, దట్ ఈస్ సపోజ్ ఇఫ్ ఎనీ అదర్ ఫ్రేమ్ ఈస్ టేకెన్ ఫ్రమ్ T4 దేర్, అండ్ ఇఫ్ ఎనీ అదర్ ఫ్రేమ్ ఈస్ టేకెన్ ఫ్రమ్ T5 దేర్. సో ఇప్పుడు and how much amount of time it is going to be even though we are having the number of frames from the different terminal devices, how much amount of time it is going to be affected? Yes, anyone? ఎన్ని నెంబర్ ఆఫ్ ఫ్రేమ్స్ ఉన్నప్పటికీ ఎంత అమౌంట్ ఆఫ్ టైమ్ మాక్సిమం ఎఫెక్ట్ అవ్వగలదు ఈ ఫ్రేమ్? See, we are having let us consider another frame T5 is there. So T5 is also in collision with this, T2 is in collision, T3 is in collision, T4 is in collision. So what is the maximum amount of time it may comes under collision? What is the maximum amount of time it comes under collision? Yes, this itself. So what is the time there? That is a TF value. And what is the total time it can take for the transfer of that particular frame? TF value. That means the TF is the propagation time of one frame, and along with that, the same amount of time is going to be travel if there is any collision with another frames. అంటే ఈ రిమైనింగ్ అన్ని ఫ్రేమ్స్ తోటి కొలిజన్ ఉన్నప్పటికీ ఇట్ కెన్ కమ్ అవుట్ ఆఫ్ ఫ్రమ్ ద కొలిజన్ స్టాటస్ ఆఫ్టర్ ద కంప్లీషన్ ఆఫ్ TF, and it can take the another TF time for the propagation of that particular frame. Yes, am I right or not? See, if all the number of frames are going to be in collision, and how much amount of time it will be affected in the collision, the maximum amount of time it can affected with the collision is the TF itself. And once the collision time is over, it will come out of from the collision there, and the maximum and the how much amount of time it can take to travel is it is again TF value. అంటే ఒక ఫ్రేమ్ కొలిజన్, ఒక ఫ్రేమ్ ఇంకొక ఫ్రేమ్ తో కొలిజన్ జరిగినప్పటికీ the maximum amount of time each and every frame is taking for the transmission purpose from the any station to the any station is a 2TF value. Yes, why? Because the time taken by each and every frame to travel is TF, and the maximum amount of time it may collide with another frame from any one of the terminals is the TF value. So the maximum amount of time it can take is a 2TF value. So this 2TF is called as a vulnerable period. సో ఒక ఫ్రేమ్ కొలిజన్ గా ఉన్నప్పటికీ కొలిజన్ నుంచి కాకుండా బయటకు వచ్చింది, కొలిజన్ నుంచి బయటకు రావాలంటే హౌ మచ్ టైమ్ ఇట్ ఈస్ టేకింగ్ ద TF వాల్యూ, అండ్ అగైన్ దట్ పర్టికులర్ ఫ్రేమ్ ఈస్ టేకింగ్ హౌ మచ్ అమౌంట్ ఆఫ్ టైమ్ TF వాల్యూ. That means so it come undergo the period of vulnerable period of the 2TF for the successful transfer of each and every frame from one terminal to the another source station. That's one thing. That is the one principle. And second one is, after taking the TF value for the initialization of the frame from any one of the terminal, how much time it is taking to travel from one terminal to the source station? That means during this particular MAC unit, whatever the MAC control unit is there, this particular MAC unit is going to take some amount of time for the purpose of propagation of that particular frame from one terminal to the central node. So let us define the TP value. Suppose during TP, the frame is transmitted from terminal to the central node, and again the terminal has to get the acknowledgement from central node to this particular terminal in order to represent that the successfully the frame is reached. As we discussed in the flow control, it has to send the frame, at the same time it has to get the acknowledgement there. So the terminal has to send over the information to the central node. ఈ టెర్మినల్ ఒక ఫ్రేమ్ను పంపించాలి అంటే ఈ టెర్మినల్ దగ్గర నుంచి వచ్చే ఫ్రేమ్ ఎంత టైం దాటి ఫ్రేమ్ ఫ్రీగా రిలీజ్ అవుతుంది అంటే దట్ మచ్ అమౌంట్ ఆఫ్ వల్నరబుల్ పీరియడ్. సో ఇట్ కెన్ కమ్ అవుట్ ఆఫ్ ఫ్రమ్ ద వల్నరబుల్ పీరియడ్ for the free release of the frame from any one of the terminal for secure transmission, and again it is taking some propagation time to travel from terminal to this particular central node. So let us take that is an TP, and again to receive the acknowledgement, assume that the same amount of propagation time it is taking that. So totally how much time it is taking now? The 2TF is a vulnerable period for the releasing of a frame without any collision, and the 2TP is the propagation time it is taking for the transfer of the frame to the desired central node and to receive the acknowledgement also. So this is the 2TF and the 2TP value. So now in order to transfer the next frame, in order to transfer the next frame successfully, how much amount of time the next frame has to wait? See, I'm taking one frame there, and I'm taking it's from terminal 1 and it is from terminal 2 there. సో ఇప్పుడు టెర్మినల్ 1 అయినా కొలిజన్ లేకుండా ట్రాన్స్ఫర్ అవ్వాలి, లేదా టెర్మినల్ 2 అయినా కానీ కొలిజన్ లేకుండా ట్రాన్స్ఫర్ అవ్వాలి అంటే వాట్ ఈస్ ద పీరియడ్ యూ షుడ్ గెట్ ఫైనల్లీ? Both the frames are going to be taking the time period of TF for the traveling purpose. That is a frame time period. So any one of the frame, either from T1 or from T2, has to complete the period of the 2TF value. That means, what is the total difference between these period is, suppose at the time of T0 they are going to be collide, the total time in between these two particular frames must be 2TF to come out of from the collision. That means here the time must be T0 plus TF, and here must be T0 minus 2TF. So what is the difference between these time? T0 plus TF minus T0 plus 2TF. Sorry, is T0 plus TF and T0 minus TF. So at the time of collision, it may be T plus TF or it may be T0 minus TF. So what is the total time in between this? T plus T0 plus TF minus T0 plus TF. So it is what is the total value? It is equal to 2TF value. That will be the one vulnerable period. That means when two frames are going to be in collision, as we calculated here, this much amount of time it is going to be take to come out of the collision. So if two frames are undergo a collision, okay, so up to after which time period the frame is going to be come out of from the collision is a 2TF value. And next, after taking the 2TF for a particular frame to come out of the collision, next it has to propagate to the central node, and again it has to get the acknowledgement. So how much time it is going to be taking? It's a 2TP value. That means once frame is released, and the next frame will be released only when the time period is going to be completed 2TF and a 2TP value. That means for the release of the next frame, suppose if it is the frame of the terminal 1, in order to release the next frame without any collision, this much amount of time it has to wait. Okay, leave that the propagation delay. So how much amount of time it has to wait? యాక్చువల్గా T2 కూడా ఎంత టైం ఉంటుంది ఫ్రేమ్ ట్రాన్స్మిట్ చేయడానికి? టీఎఫ్ఏ. కానీ ఇప్పుడు T2 అనేది టీఎఫ్ ప్రీవియస్ ఫ్రేమ్ యొక్క టీఎఫ్ మాత్రమే వెయిట్ చేయట్లా. ఎంత టైం వెయిట్ చేస్తుంది? ఇట్ ఈస్ వెయిటింగ్ దట్ 2 times that of the TF value, even though the second frame is going to be transmitted after the completion of the previous frame. But how much time it is going to be taking to transfer it? Only TF. But how much time the next frame is waiting is the 2 times that of the TF value. Okay, so in the Aloha protocol, how the number of frames are going to be transmitting from each and every terminal to the central node is, this is the basic principle they are using. So one by one terminal is going to be releasing its frame, but if they are in collision, to come out of the collision they are going to be undergone through the vulnerable period, and after the completion of the vulnerable period and the propagation delay, the next frame is going to be released. Suppose if this particular frame is going to be in collision, ఇప్పుడు ఇదే ఫ్రేమ్ మళ్ళీ రిలీజ్ చేయాలన్నా కానీ ద సేమ్ అమౌంట్ ఆఫ్ వల్నరబుల్ పీరియడ్ హ్యాస్ టు బి టేక్స్ ప్లేస్. అంటే after this particular time period, so whatever this particular time period is, it is called as the back off period. So back off period in a sense, after this particular time instant, the next frame may be released, or it can retransmit the previous frame also. Suppose if the previous frame is lost or the damaged, again the retransmission has to take place. So when the retransmission has to take place after the completion of this particular 2TPF and 2TP, again the retransmission is going to be takes place. So this much amount of time is going to be elapsed. After the elapsing of this particular time period, the next frame is going to be released. So like that, one by one frame from one by one terminal is going to be takes place. So this is the basic principle of Aloha architecture. But here the efficiency of this particular Aloha system, okay, this particular basic Aloha mechanism can be called as pure Aloha protocol. Okay, in the pure Aloha protocol, what is the scenario they are utilizing is, at any time instant any terminal device can transmit. అంటే ఒక టెర్మినల్ అనేది ఒక స్పెసిఫైడ్ టైంలోనే ఫ్రేమ్ రిలీజ్ చేయాలనే రూల్ ఏం లేదు. ఒక టెర్మినల్లో ఎప్పుడు పడితే అప్పుడు ఆ ఫ్రేమ్ని రిలీజ్ చేసుకోవచ్చు. ఎందుకని ఇట్స్ ఫ్రీ ఫర్ ఆల్. సో ఆల్ ద టెర్మినల్స్ ఆర్ హ్యావింగ్ ద ఛాన్స్ టు రిలీజ్ దేర్ ఫ్రేమ్స్ ఈవెన్ దో దే ఆర్ గోయింగ్ టు బి కొలైడ్ విత్ అనదర్ టెర్మినల్స్ ఆర్ నాట్. సో దే ఆర్ నాట్ బోదరింగ్. But when they are in collision, then that particular frame is going to be in waiting state. So with that, the efficiency of this particular pure Aloha system is going to be reduced. Why? Because to release the next frame, how much amount of time this particular frame has to wait is 2 TF. యాక్చువల్గా ప్రీవియస్ ఫ్రేమ్ ట్రాన్స్మిట్ అవడానికి దాని టైం టీఎఫ్ఏ, కానీ ఆ ఫ్రేమ్ ఎంత టైం వెయిట్ చేయాలంటే 2 TF వెయిట్ చేయాలి. వై? బికాస్ ఆ ఫ్రేమ్ ఒకవేళ కొలీజన్ జరిగితే మాక్సిమం ఎంతవరకు కొలీజన్ జరగగలదు అంటే 2 TF వాల్యూ వరకు జరగవచ్చు. అంటే టీఎఫ్ అనేది వేరియబుల్ పీరియడ్ అక్కడ. అంటే కొలీజన్ టైం ఇంటర్వల్ అనేది వేరియబుల్ పీరియడ్. సో ఒక్కదాంతోనే కొలీజన్ జరిగింది అనుకోండి, ఇట్ ఈస్ లెస్ దాన్ టీఎఫ్. రెండు ఫ్రేమ్స్ కొలీజన్ జరిగింది అనుకోండి, ఇట్ ఈస్ ఆల్సో లెస్ దాన్ టీఎఫ్. Suppose if it is collision with another frame like this, so during this period it is collide with T2, during this period it is collide with this, during this period it is in collision with this, and a total TF collision జరిగింది కాబట్టి, so total TF plus TF 2 TF it has to wait the next frame. అంటే in the pure Aloha all the terminals are releasing their frames on their wish only. That means there is no restriction and there is no rule is there in order to release the frames from that particular terminals itself. సో ఇన్ ఆర్డర్ టు ఎలిమినేట్ దట్ పర్టికులర్ ప్రాబ్లం, ఎందుకు అంటే అలా టెర్మినల్స్ ఎప్పుడు పడితే అప్పుడు ఎలా పడితే అలా రిలీజ్ చేయటం వల్ల ద టెర్మినల్స్ ఆర్ అండర్గోయింగ్ ద collision process and they have to come out from the collision process. Meanwhile, the efficiency of the complete system is going to be decreases. But firstly, it is introduced as Aloha system in order to transmit and very securely, even though they are waiting time. Suppose if the number of terminals are going to be increased, automatically the waiting time of each and every frame is going to be increased. So to overcome the problem of this particular pure Aloha system, pure Aloha protocol, another protocol implemented, that is a slotted Aloha protocol. And it is implemented by the other robots. So in the slotted Aloha, how we are going to improve the efficiency of the system? Okay, only we are going to improve the efficiency of this particular system. Okay, simply we can say that how we are going to improve the efficiency in the pure Aloha by this particular slotted Aloha is, slotted Aloha means we are going to assign some number of slots for each and every terminal. Okay, in a slotted Aloha, what we are doing is we are assigning slots for terminals. Okay, sorry, slots for terminals కాదు, it is going to be assigning the different slots, and these different slots may be utilized by any one of the terminals. Suppose let us take that the slots as T1, T2, T3, T4 and so on. Suppose if first terminal T1 is released the frame at the time slot of T1, and there is no restriction to release the number of frames at a particular slot. అంటే ఒక స్లాట్ లో ఒక టెర్మినల్ డివైస్ మాత్రమే ఫ్రేమ్ పంపించాలని రూలే లేదు. సో ఎనీ నెంబర్ ఆఫ్ టెర్మినల్స్ can release the frames only, but only at the time slots only. But here in the pure Aloha, what we are observed is there is no time, there is no specified time at which particular time the terminals are releasing the data. But here the terminals has to release the data only at these specified terminals only. The terminals has to release the data or the frames only at these particular time slots only. అంటే ఇప్పుడు suppose T2, if the terminal T2 is releasing that particular frame, so is there any collision there? Why? Because only terminal releases the frame. Suppose at T2, if it released another the terminal T3 is also released the frame. So at the slot of T2, two frames are going to be in transmission. So almost, suppose if you want to transmit T2, it is going to be in collision with T3. If you want to transmit T3, it is in collision with the T2. So now, how much time the T3 has to wait? How much time the T3 has to wait? For T1, take the frame time as T2 and T2 frame time as TF. సో ఇప్పుడు T3 collision నుంచి బయట వచ్చి T3 స్లాట్ దగ్గర ట్రాన్స్మిట్ చేయొచ్చు. అంటే ఇప్పుడు ఎంత టైం వెయిట్ చేయాలి T3 అనేది? At this slot, only T2 can transfer, even though the T3 is released. So T3 is in collision with the T2. So T3 collision నుంచి బయటకు వచ్చి ట్రాన్స్మిట్ చేయాలి అంటే how much time it has to wait? Let's respond. T2 ట్రాన్స్మిట్ అయ్యేంత వరకు వెయిట్ చేయాలి. అంటే T2 ఎంత టైం తీసుకుంటుంది ట్రాన్స్మిట్ చేయడానికి? T2 ఎంత తీసుకుంటుంది టైం? Here I am showing. Respond anyone. Yeah, is there anyone in the class who is listening or simply log in? Let's say yes or no for this question. Yes or no?
Yes, sir.
Okay, right. See, the terminal 2 is released the data frame here. The T3 is also released the data frame here. They are in collision. At this slot, they are releasing the frames, but T2 is going to be take the action, but T3 is in collision. So T3 again it has to be retransmitted. So when it can retransmitted after the completion of frame time of your terminal 2. So the terminal 2 is going to be taking the time of TF. So the TF has to wait only TF. That means there is no vulnerable period for this. The vulnerable period for each and every frame is only TF itself. Why? Because the another frame is also waiting the period of TF only. But what is the vulnerable period of the slotted aloha there? What is the vulnerable period of the slotted aloha?
2 TFs.
Yes, it is equal to the 2 TF value. But here, every frame is waiting how much period, even though it is in collision with another frame of the another terminal device. So how much time it is waiting is only the TF value. That means in the slotted aloha, as we are allotted the fixed time slots to release the frames, every frame, even though any frame is in collision with that, every frame has to wait only the period of the TF only instead of a 2 TF. That means we are reducing the vulnerable period of pure aloha system, that is a 2 TF into the TF value into the slotted aloha there. That is the advantage of a slotted aloha. So in the slotted aloha, only with the TF we are going to transfer another frame. So at this slot the T3 can be transferred, and at this slot the T4 can be transferred, and at the slot another T4 is going to be transferred. Even though in the pure aloha, one by one frame is transmitting there. Here also one by one frame is transmitting. But there in the pure aloha, as the number of terminals are releasing the frames at their time, at their wish time, means దానికి ఇష్టం వచ్చినట్టు ఫ్రేమ్స్ రిలీజ్ చేస్తుంది కాబట్టి అన్ని ఫ్రేమ్స్ తో ఎన్ని కొలిజన్స్ అయితే ఉన్నాయో మాక్సిమం టీఎఫ్ వరకు వెయిట్ చేసి నెక్స్ట్ ఫ్రేమ్ హ్యాస్ టు ట్రాన్స్మిట్ దేర్. But as you are defining the different time slots here, only the TF time has to wait for each and every frame, and we can release the frame after the elapsing of the TF period. That is advantage we are going to getting in the slotted aloha there. Okay, this is about the pure aloha and slotted aloha, and without any damage or without any last. But last damage and it is nothing but in collision. That is an error. So flow control and error control we are achieving. So how we are achieving is by waiting this amount of time, we are going to releasing another frame. Okay, like this we are going to completing the pure and the slotted aloha. Again, in aloha system, in the complete aloha system also we are having the problem. Okay, what is that problem is, ఓకే, అండ్ మై క్వశ్చన్ ఈజ్, ఇప్పుడు స్లాటెడ్ అలోహాలో ప్రతి ఫ్రేమ్ ట్రాన్స్మిట్ చేయడానికి ఓన్లీ టీఎఫ్ఏ వెయిట్ చేస్తుంది ఇన్స్టెడ్ ఆఫ్ 2TF. Suppose for pure Aloha, by waiting the time of 2TF, if you are getting the efficiency as 30%, then how much efficiency improvement we are going to get in slotted Aloha? If you are getting the efficiency of 30% in the pure Aloha system with the maintenance of the waiting period as 2TF, here we are waiting only TF. Here we are waiting only TF there. So in the slotted Aloha, how much amount of efficiency improvement we are having? That means simply it will be doubled. That means 30% is going to increase it to the 60%. Why? Because the waiting time is going to reduce to half. So automatically the throughput or the efficiency of this particular slotted system will be double than that of this particular pure Aloha system. So based on this particular parameter, how far we are improving the double time of the efficiency when compared with your pure Aloha, a mathematical relation is made in order to compare the efficiency of this particular pure Aloha and slotted Aloha system. Okay, here with this we can understand that how an efficiency is improved in your slotted Aloha when compared with your pure Aloha. See here, an expression is going to be used in order to represent that pure Aloha is suppose it is nothing but the half of the slotted Aloha. So in order to relate that, we are using an exponential term, that is g into e power minus 2g for pure Aloha and g into e power minus g for a slotted Aloha there. See, where g is representing that here g is nothing but an attempts in the sense what is the load we are giving, or what is the traffic we are giving that. Suppose if you are giving that a low traffic, let us say that 0.5. So here we are going to get a 0.5 into e power minus 2 into 0.5 means e power minus 2. That is 1 by e square we are getting that. At the same time, at 0.5, we are getting that g into e power minus g. Okay, take one. We will understand clearly. That is 1 into e power minus 2, 1 by e square, and it is 1 into e power minus 1. That is 1 by e. That means almost the slotted Aloha, in the sense it is going to be double when compared with your pure Aloha. So if you observe here, what is the efficiency we are getting is, here we are getting this much of efficiency, and here we are going to getting the that this much of efficiency. Means that 1 by e power 2 and 1 by e, in the sense the efficiency is going to be doubled in the slotted Aloha when compared with your pure Aloha. Only the reason is the waiting time is going to be half in the slotted Aloha, that is only the TF, but in the pure Aloha it is equal to the 2TF, that is nothing but vulnerable period. That much amount of time it is waiting in the pure Aloha, but in the slotted only it is TF value, and that we are achieving by providing some slots, fixed time slots there. But in pure, we are not having any time slots for any terminal device. So at any time, the terminal may wish to send the data there. Okay, that much of advantage we are having in the slotted Aloha. Okay, here not only with this, we are going to stop the Aloha protocol. Again, in the basic Aloha also, we are having the problem. That is, what is the problem? Again, why you are going to getting the 100% efficiency upon releasing all the frames from all the terminal devices is, see, ఇప్పుడు ఈ సెకండ్ టైమ్ స్లాట్స్ దగ్గర టెర్మినల్ 2 అండ్ టెర్మినల్ 3 ఆర్ రిలీజింగ్ ద ఫ్రేమ్స్, and in pure Aloha at this particular time the T2 is releasing, T4 is releasing, and T3 is also releasing the frames. Means that we are going to getting the collision upon releasing the frames by the multiple number of terminal devices. Means that every terminal is not going to be bothering about the another terminal device. Ante in your centralized networking environment, all these terminals are not going to be in communication. Are not going to be in communication. Means it is not having the information regarding this particular T2 terminal device, whether it is busy or idle, or this particular T2 is also not going to be bothering the condition of this particular T1, whether it is busy or idle. Means that as we are not having the information, as we are not having the relation with all the terminals, we are getting this problem only. Why you are going to getting this collision problem? As the terminals are not having any relation. అంటే T2 transmit చేస్తుంది, T3 transmit చేస్తుంది, means that the T3 is not having the relation with the T2, whether this particular T2 is idle or the T2 is busy. So that means all the terminal devices are not having in relation. Okay, I will say simple example. In the class, if the 10 people are talking, so if all the 10 people are talking at the same time, we are not going to we are not going to hear on even single voice clearly. Suppose if anyone is found that if one member is talking, and he found that so somebody is talking that, so I have to wait until the conversation of other people. That means the second is going to take the chance to stop until the completion of another people. So if one man is completed the conversation, the next is going to be start, because the second one is going to be found that some other is talking. Means that we are going to follow the principle of LPT. That means listen before talking. Listen before talking in the sense, before going to talk any people, he is going to listen, is there anyone is talking or not. Suppose before going to start the releasing of the frame by any other terminal, this particular terminal is going to take care of the another terminal if that particular is going to releasing any frame or not. So if it is maintaining the relation with another terminal device, if there is any communication in between another terminal device, then this particular terminal is going to wait that particular instant of time, and then he is going to be start. Ante this particular, when you are going to start the talking, when you are going to listen that some other is talking, here I'm going to wait, and once it is completed, I'm going to start. Then only my voice is going to be clear. Suppose if all the people are going to be continuously talking, my voice is not going to be clear. So when I listen that somebody is talking, and I'm going to wait that amount of time, and then I'm going to start my talking. So here also the same principle is going to be applicable. If one terminal device is in transmission, other terminal is going to wait until that particular completion time. Means that if you are having the relation from one terminal to the another terminal, then there is no collision there, and simply we can transmit there. And no collision in the sense that much amount of time we are meeting, but we are not going to problem of losing or damaging of any frame of a particular terminal device. So what we are going to do is we are going to sensing the status of each and every terminal before going to releasing the frame from a particular terminal device. So that type of technique is called as a CSMA protocol. So what is the problem in the complete Aloha protocol is all the terminals are not going to be in communication, and all the terminals are not going to know are not going to are not maintaining any status of any terminal device, whether the terminal is in releasing the frame status, or whether terminal is free, or whether the terminal is busy with some other purpose, is not maintaining any relation. Suppose if you are sensing the status of all the terminal device, then we can send the frames very securely there. So T1 transmit చేసేటప్పుడు అన్ని terminals we are going to sense. So if all the terminals are found idle, then T1 is going to be start releasing the frame, and it is sending. And when T2 is sending, it is sensing all the and all the remaining terminals, and if it is found that they are idle, then the T2 is going to take the action. And if they are busy, and T3 కూడా ఇక్కడ రిలీజ్ చేస్తుంది కాబట్టి, అంటే T3 is busy means T3 is going to be in waiting. Why? Because the T3 is found that it is sending some frame, so the T3 is going to wait until the completion of this particular T3 process. So like that, from the in the Aloha protocol, what is the problem? On the complete pure Aloha and the slotted Aloha, all the terminal devices are not maintaining any relation there. So again, we are going for another protocol, that is a CSMA protocol. That is, we are accessing multiple, that is a multiple access, means that we are accessing a multiple number of devices. It's a multiple access approach, but we are going to checking that carrier sensing. So what the terminal is going to be carrying the data, that is, we are going to sense each and every terminal. That is about a CSMA protocol. So again after Aloha protocol, we are having a CSMA protocol there. This CSMA protocol is going to be senses all the terminal devices one by one, and then it is going to be sending the information. And again, during the sensing also, it is going to follow whether it is persistent or not persistent. So based on the persistency, again the CSMA protocols are also going to be divided into different algorithms that we will continue in the next class. Okay, this is about Aloha Protocol. So for transferring the information from multiple number of terminals in the secure manner towards a centralized network. Okay, right. Thank you. We will continue that CSMA from next class.